2 months here. This is review of Algebra 1, okay? Everything we've done up to this point, you should have done in Algebra 1. And we will still continue to work on some of these Algebra 1 skills. Now, what we get taught in Algebra 1, I don't really know anymore. But certainly when I taught Algebra 1 10 years ago, it was absolutely, we spent all of our time solving linear equations and graphing. So we're doing some graphing now, but to start, we're talking about slope. So I have a question for you. Given a picture, what is the slope of the lines below? So this is line A. I'm going to call this line B, and this line C. These are very nice graphs. And the reason they're nice graphs is because they're nicely labeled. You can see I've even highlighted a couple of points. And I just want to talk about, I've been having questions about, where are the points? What if the points weren't highlighted? If I hadn't boldened those 2 points, how many points make up this big long line? An infinite number of points make up that line. And what happened is we have a billion ordered pairs that are smushed so tightly together, they form a solid line. Okay? And so you can pick any 2 points you want. I could pick this crazy point right there, which is, I don't know, negative 0.8, negative 2.2. I don't know what that point is, but it's somewhere around there. Okay? Is that a smart point to pick? No, because it's crazy. It doesn't fall on a nice grid line. So on your homework today, you're going to see some pictures, and they don't necessarily have darkened points for you. Pick 2 points that fall nicely where grid lines and the line itself intersect. You can pick any 2 easy points, okay? Now, tell me what you know about slope. Yes, Ryan. It is a ratio. It is a ratio. It is a ratio. Grace. So very close, and we're going to use that next. There's an alliteration. Okay, so y equals mx plus b is slope-intercept form. That is the equation of a line, and that is not what we're doing today. Rise over run. Very good. So for this, I'm looking for rise over run. I love this alliteration. Whenever we're given a nice picture of a line, rise over run is a great way to calculate the slope. So in order to find the slope, what we're going to do is we are going to highlight 2 points on my line, because I need 2 points to find a slope. And I want to start with the point that's furthest to the left. So would you say this point at the origin or this point at 1, 3? Which one is further to the left? The origin right here is further to the left. We always want to start from the left and move to the right. So I'm going to choose the point that's further to the left, and I'm going to figure out my slope by talking about the rise over the run. So from the left side point, I'm going to stair step over to this point. So in order to go stair stepping to get to this point, what would I have to do? I'd have to go up how many? Up 3. Up 1, up 2, up 3 spaces. And then I have to run how many? 1. What's the slope of this line? 3 over 1 or just 3? Okay. Is the slope positive or negative? Positive. It's going uphill from left to right. We start on the left side of the graph, we'd be climbing a mountain. It's an uphill slope, a positive slope, okay? On the second one, I have 2 highlighted points. Which one is furthest to the left? The one on the left. Yeah. Okay. Yeah, over here, negative 2, 1 is the furthest to the left. So I'm going to start with this point, and I'm going to stair step to the next point, moving left to right. So how do I get there? What do I have to do first? I have to go down 1. Well, in down 1, that means negative 1. So my slope, my rise is negative 1. And then what do I have to do? Go over 2. Run 2 units. So my slope is down 1 over 2. Down 1 over 2. Is this a positive or negative slope? Negative slope. Yeah, it has a negative. It's going downhill from left to right. I'm starting up high, and the mountain is going down. All right, negative slope, downhill from left to right. What's the slope of this line? The slope is 0. The process still works the same, actually. If I start with my leftmost point, how much up or down do I have to go? 0. I go up 0, and then how much do I have to run? 2, 3, 4, that doesn't matter. What is 0 divided by any number? 0. 0 is the slope of any horizontal line. A horizontal line has a 0 slope. Is that a positive slope or a negative slope? No, it's directly in the middle. It has no positive slope. It doesn't have a negative slope. It's right in between positive land and negative land. Okay? All right, so to start your work, this is what you're doing. Just calculating slope by counting the slope. Rise over run. Easy to do. Okay? Pick a couple points. So here we go. Example 1. Again, please, you need to write these directions. I don't know how many questions I answered where they're like, what am I supposed to do? And I'm like, where are your notes? And they're like, they're right here. I'm like, well, open your notes. Because my notes are very specific. Example 1, find the slope. You don't really need to write of the line passing through the points. You can skip that. Find the slope. And then the other important part. Tell if it rises, falls, is horizontal or vertical. Tell if it rises, falls, is horizontal or vertical. Rises, meaning it has a positive slope. Falls, meaning it's a negative slope. Horizontal or vertical line. Okay? Now, Grace, you told me a formula for slope, which is great. We are going to need a formula for this. I don't have to graph these points. I can just use a nice formula that's super easy. Slope equals, we use the letter M to represent slope. I actually read it one year. The M, the reason it's an M is I think it's from a Latin word that means slope. So slope in Latin starts with an M, and that's why we use M. All right, Grace, you told me a formula. It was almost correct. And you said, what did you say? So it's subtraction. All right, so slope, I can use rise over run, and I love that because it's a nice alliteration, right? Rise over run, rise over run. It's easy to say, easy to remember. I'm going to add on to that. We're going to rise with the y's. Like that, rise with the y's. That's your clue that the y value should be on top. Y2 minus y1. What's on the bottom? X2 minus x1, okay? This is the formula for slope, and I hope that, after you do your work today, that you have it memorized. But I love rise with the y's. That just gives you a clue that the y values have to be on top, okay, in an ordered pair. Rise with the y. All right, you got to write that down. Rise with the y's. Y2 minus y1 over x2 minus x sub 1. Okay, so I have an ordered pair, 1, negative 5. This is my first ordered pair. So I'm going to call this x sub 1 and y sub 1. They both get the same subscript because they're both from the same ordered pair, the first ordered pair. So what am I going to call the second ordered pair? X sub 2, y sub 2. And now I can calculate the slope by subtracting. I'm going to subtract y sub 2, subtract y sub 1. 3 minus a negative 5. 3 minus a negative 5. Over x sub 2 minus x sub 1. X sub 2, negative 2 minus the 1. Negative 2 minus the 1. What is 3 minus a negative 5? 3 plus 5 minus a negative. Negative times negative is positive. So this becomes 3 plus 5, or 8. And then a negative 2 and a negative 1 make negative 3. So this is 8 over negative 3, or negative 8/3 is the same thing. Is this slope positive or negative? Negative. Does it rise or fall? Falls. Okay, second point here. I'm going to again label x1, y1 because that's my first ordered pair. x2, y2. And ladies and gentlemen, if you can go from the ordered pair to this, fabulous. I don't have to see this step if you can do it in your head. Hopefully this is entirely review for you and it's super easy. That's what this should be. It should all be super easy, okay? So if you can jump from ordered pair to slope answer, fantastic, okay? So again, if I want to find the slope, I'm subtracting rise with the y's. So I'm going to start with the y values. 5 minus a negative 1 over the x's. 2 minus a 2. What is 5 minus a negative 1? 6. What's 2 minus 2? 0. What happens when the 0 is under? It's true. What's the word? When the 0 is under, it's undefined. Okay? When the 0 is under, it's undefined. This is an undefined slope, which is a vertical line. Okay? It works with rise over run as well. If I was trying to graph a line that had an undefined slope, it has a rise of 6, which means if I pick a starting point and then I count up 6, 1, 2, 3, 4, 5, 6, and then I do a run of 0, I would go right 0 units. So it's just 2 points stacked on top of each other, which is a vertical line. All right. Do you have any questions on slope? Okay. Good. Hopefully that's super old, easy stuff. All right. Example 2. Example 2. Tell whether the lines are parallel, perpendicular, or either. So again, you can abbreviate, but you need the example 2, and you're going to tell if they're parallel, perpendicular, or neither. And if you know the abbreviations, the geometry, parallel, perpendicular, or neither, you can use those symbols to represent them as well. Yeah. Tell whether the lines are parallel, perpendicular, or neither. Okay, so again, we need some information. Tell whether the lines are parallel, perpendicular, or neither. Tell me about parallel lines. What kind of slopes do parallel lines have? They have, parallel lines have the same slopes. They have the same slopes. That's super important. You should write that down. Parallel lines have the same slopes. Now, the harder one, perpendicular lines. What do perpendicular lines have? I love how my handwriting is super neat. Perpendicular lines they're not the same. It's already used. Opposite is part of it. Opposite reciprocal slopes. So why don't you talk about what that means? Opposite reciprocal, C-I-P-R-O-C-A-L, slopes. Perpendicular lines have opposite reciprocal slopes. So let's talk about reciprocal. What are reciprocals? Give me an example of reciprocals. Ryan. Yes, 3/2 and 2/3. Those are reciprocals. Reciprocals flip fractions. What does opposite mean? Let me ask it another way. What's the opposite of -5? Oh, it's +5. Okay. What's the opposite of 12? -12. What does opposite mean? One is positive, one is negative. Okay? 3/2 is perpendicular to 2/3. So that's an example of opposite reciprocals. Okay? Change the sign, flip the fraction. So with that information, once again, all we need to do is calculate slope. Everything we're doing today is just slope. So I'm going to start by finding the slope of line 1. So I'm going to use M sub 1 as my notation. This would be the slope and line 1 because we're talking about line 1. So I put a little subscript 1 there. And I want to calculate the slope. y2 minus y1, that's going to be -2 minus a -2 over x2 minus x1. x2 minus x1 would be 3 minus 1. What happens when we have -2 minus a -2? It's 0. Yeah, minus a negative. Negative times negative turns to a giant positive sign. So we have -2 plus 2, which is 0. Over 2. What is 0 divided by any number? 0. What kind of line is this? Horizontal line. 0 slope. It's not positive, it's not negative, it's flat. 0 beats per minute. All right. Line 2, I'm going to find the slope of line 2. So that's M sub 2 because this is my second line. M sub 2. So again, I want to calculate the slope. y2 minus y1. 4 minus 4. Over x2 minus x1. So 0 minus a -5. Okay. What is 4 minus 4? 0. And 0 minus a -5. What is 0 divided by any number? 0. Tell me about these two lines. Are they parallel, perpendicular, or neither? They're parallel. Why do we know they're parallel? Because they have the same slope. Yes. Parallel lines. Because they have the same slope. Parallel lines. Because they have the same slope. All right. I'm going to do the same thing for letter B here. One more time. I'm going to find the slope for line 1. The slope for line 1, y2 minus y1. So -1 minus 3 over x2 minus x1. 3 minus a -3. What is -1 minus 3? -4. And 3 minus a -3? 6. Again, minus a negative. Negative times negative turns to positive. So 3 plus 3 is 6. That reduces to -2/3. And then I want to compare that to the slope for line 2. The slope for line 2. y2 minus y1. That's going to be 3 minus a -2. Over x2 minus x1. 2 minus a -2. Negative times negative turns positive. 3 plus 2 is 5. And here we're going to get 4. That one doesn't reduce. Tell me about these slopes. Are they parallel? No, they're not the same. Are they opposite reciprocals? No, which means it must be neither. They are not parallel. They're not perpendicular. They're nothing. Nothing extraordinary. Okay. I have one more. All right, example 3. Example 3, last thing. Last thing, example 3. Find the average rate of change. Find the average rate of change. Find the average rate of change in temperature. If at 2 p.m. it was 100 degrees, and then at 5 a.m. it was 68 degrees. Okay. Guess what? Average rate of change. Average rate of change is equal to slope. It's fancy language, all right? It is the same thing as slope, but it's slope with units. That is the only distinction, okay? We're just talking about real life things. Money and hours, okay, which I calculate all the time, or dollars per item when I go grocery shopping. That's rate of change. And I always compare the rate of change of, similar items to get the best value, okay? So if I want to find the slope, then I need ordered pairs. And when I read this, I actually have easy ordered pairs right off the bat. The first ordered pair says at 2 p.m., it was 100 degrees Fahrenheit. There's an ordered pair. At 2 p.m., it was 100 degrees. It was hot at 2 p.m. And then a whole lot of time passed. What's another ordered pair? At 5 a.m., it was 68 degrees. Did the temperature increase or decrease? It decreased, right? So we're going to go ahead and find average rate of change is just slope, ladies and gentlemen. Super easy. The average rate of change in temperature. So we want temperature on top. So 68 degrees Fahrenheit minus 100 degrees Fahrenheit. Y2 minus Y1. Same thing. The only difference? Units. Over. Now this is where it gets a little tricky. Time is different. So I don't, 5 a.m. minus 2 p.m. is very weird. So we're going to talk a little bit differently. This is hours. So we need, I can't do 5 minus 2. It's not 3. Okay, we're talking time. At 2 p.m., the temperature was 100 degrees. How much time passed? How many hours passed from 2 p.m. to 5 a.m.? Colin. 15 hours. Explain how you got 15 hours. Okay, Ryan, do you have an explanation for me?
So you add 10, and then you get 12, which is midnight, and then 5.
Okay, so starting at 2 p.m., lots of ways to think about this. It's 2 p.m. If I go a full 12 hours, now what time is it? It's 2 a.m., right? And then 2 a.m., 3 a.m., 4 a.m., 5 a.m., 3 more hours. So 12 whole hours and 3 more hours, total of 15 hours have passed. So 68 degrees minus 100 degrees is what? Down 32 degrees. Again, there's units on there. Over the course of 15 hours. And then what I'm going to do is just divide these. Negative 32 divided by 15. And I get negative 2.13. Guess what? You can divide those numbers and then guess what the units are? Degrees Fahrenheit per hour. This is rate of change. It says the temperature is changing down a little more than 2 degrees, down 2 degrees per hour, every hour. And that's rate of change. It's just talking about how much the temperature is changing per hour. Okay? Slope with units. Do you have any questions for me, ladies and gentlemen? All right, please